positive charge. Okay, let me show you another example. Okay, so here's an atom of oxygen. The atom that I've drawn here has 8 protons here in the nucleus, and it has 8 electrons outside.
You should have your book open to page 94, unless you've already done it. Do you have a book? Yeah? Okay, cool. Page 94. So we're looking now at oxygen. Oh, by the way, if there is anyone who is like finished all of this and wants some practice with average atomic mass, I'm just going to put it on the corner of the table here. If you're bored and you'd like to do that part on Friday, there is some average atomic mass stuff right here. Okay? Now,
so we have the same number of protons and electrons, which means that the total charges balance out. Plus and minus balance out. So I have a net charge of 0, and I can say that my oxygen atom is neutral.
okay, so your oxygen atom, an atom is always what overall charge? It is always neutral. That means that the same amount of positive as negative. Okay, so it's neutral, it has no charge, so you can fill those in, okay?
It has no net charge. But oxygen can gain or lose electrons, and actually it really likes to gain 2 electrons. And here's a picture of the oxygen atom after it's gained 2 electrons. And now it still has 8 protons.
So if it has gained 2 electrons, how many electrons does it have now? It has 10. If you gain 2 negative things, what will your charge be? You're going to be negative 2 because you were neutral, you gained 2 negative, now you're negative 2.
In the nucleus. And if I count up these electrons, it now has 10 electrons instead of 8, which it had before. So now the protons and electrons don't balance out anymore, and I have more negative charge than I have positive charge. I've got 2 more electrons and protons, so that means that my total net charge is going to be 2 minus. I can write the symbol for this ion as O 2 minus to show that it has 2 minus charge, whereas this neutral guy over here, I can just write O. This is an ion because it has a charge, and there's a specific name for it. We can call this an anion, which is the word that we use to describe a negatively charged ion.
Do you remember the word for positive ion? Yes, cation. So cations are positive and anions are negative. So if you gain electrons, you gain negative things, you become a negative ion, you become an anion.
It has more electrons and protons. Okay, here's just a little bit of vocabulary for review. So an ion is an atom or a group of atoms that have a charge.
So you can go now to page 95 and fill in what ion is if you didn't manage that last day or if you were away last day. An ion is an atom or a group of atoms with a charge. So it's on page 95. So that's one of our vocabulary words, an ion, an atom or a group of atoms with a charge.
Okay, now it's possible for an atom to be neutral, which means it has no charge, means it's not an ion.
So you can define neutral. Neutral means no charge. In other words, 0.
But if something is an ion, it can be either a cation, which is what we call a positive ion, or it can be an anion, which is a negative ion.
Okay, so you can write down those definitions. Cation is a positive ion. Anion is a negative ion. And now we're going to learn what a mnemonic device is. That's a funny spelling for a word. Mnemonic. The Greek meme, with a silent M as far as I know, stands for memory. You don't need to know that, but Greek for memory. So a mnemonic device is a memory aid. Okay? Mnemonic device is a memory aid. And Tyler has a couple of mnemonic devices to help you remember that anions are negative. So we're going to listen to this.
Here's a way that I use to remember this, okay? Anion, I think of this as standing for a negative ion, okay? And then cation, you can remember this, it's really cheesy. You can remember this because cats have paws, and a cation is positive. All right? You'll never forget. I swear, you'll never forget.
Okay, so hang on. We're just going to write that down in case you missed it. Anion stands for negative ion. Okay? So that's one way of remembering that an anion is negative. If you don't like that, or you would like a different way to remember it, I have another way to remember it, and that is that anion sounds a little bit like onion. And what do onions do when you chop them up? They make you cry. And crying is negative. Not that it's always negative, I understand. A good cry can be cleansing, right? It can be a bit cathartic. But for our mnemonic device, for our memory aid, anion sounds like onions. Onions make you cry, which is negative. You can write down one of those or both of them to help you remember that negative ions are called anions. And the other one have pause, and cations are positive. Now, if you don't like that way, guess what's right in the middle of the word cation? It's a plus. There's a plus right in the middle of the word cation. Okay, so if you can't remember cats have paws, maybe that will help you. Sometimes it's nice to have two ways to remember. That way, you know, you can access both of them. I've had practice on that one. I've drawn it for years. One of the very few things that I can manage.
Okay, there's one more thing that I want to mention. I've said that an ion is an atom or a group of atoms with a charge. I haven't said anything yet about the group of atoms. So more than one atom can come together, they can stick together and form a group or a clump, and then that whole clump of atoms has a charge. When this happens, we call it a polyatomic ion, a group of atoms that have a charge. Poly means many, and atomic, you have many atoms together that form an ion. I'll talk about polyatomic ions in future videos.
Okay, so poly, what does poly mean? If you have a polygon, have you learned about polygons in math? How many sides does a polygon have? At least 3. In other words, many sides. A polygon has many sides. So poly means many. Where'd the black one go? There it is. So poly means many. So if you have polyatomic, maybe you have 4 atoms all stuck together with a charge. That's many atoms with a charge. Or maybe you have like that and it's got a 2- charge. Okay, many atoms stuck together with a charge. That's a polyatomic ion. Okay. So we are now going to go to page 96. Today's a big lesson day. We're going to take a break or two in the middle, okay, to kind of break it up. I want to get as much done today, though. There won't be homework, okay? So we're going to have a big lesson today, but there's not going to be any homework, all right? All right, page 96. Page 96. So Tyler was just showing us that ions can form. Why do they form? That's what we're going to look at now. So we're going to talk about a few things. We're going to talk about things being stable and things being unstable. I would like you all to pick up your pen or your pencil and hold it up. Okay, now I would like you to maybe not hold it up quite so high, otherwise it might break. Hold it, now let it go. What happens to it? What does it do naturally? It drops. If you want it to go back up, what do you have to do? You have to pick it up and do some work on it, okay? When the pen is up here, it has the potential to move, yes? So it has what we call potential energy. It has the potential to move. And all you have to do is let it go. And that potential is turned into motion energy. So here we have some stored energy. It's got a bunch of energy stored in it, and it could turn into motion energy. Once it hits the bottom, now I know this is not as far down as it can go, but once it hits the bottom, is it still at the same potential, or is it at a higher potential, or is it at a lower potential? Lower, because it cannot travel as far or as fast, right? Maybe I could have it drop to the floor, right? But it's still not as much as if it drops from that height all the way to the floor, okay? So things that are stable, or actually things that are unstable, we say that they have high potential energy, which we can abbreviate potential energy as PE. Potential energy is stored energy. Yeah, thank you. Just in there, please. Perfect. Thank you. So we have stored energy. Do you guys know how hydropower works? You know how we get, do you guys know how that we get a lot of our power, our electrical power in BC, it comes from rivers? Did you guys know that? If you didn't know that, a lot of our electricity in BC comes from rivers. Do you guys know what they put on a river to get electricity out of the river? Because a river is not electricity, right? What do they put? They put a dam. And what does that dam do to the water that's behind it? It stops it, okay? But what does that water naturally want to do? It wants to flow. It wants to flow downhill to a lower potential. What happens is inside the dam, there are pipes that it can go through, and those pipes lead to turbines. They're things that spin. When the water goes through, it makes those turbines spin. So we've transformed that potential energy into motion energy. Now, if you do some fancy stuff with magnets and wires, you can make that motion energy turn into electrical energy. So that's how we get electricity out of a river. Yeah? So the water's at a high potential. As it flows to a low potential, we can extract that stored energy and turn it into electrical energy. Okay? So as we go from a state which is unstable, the water doesn't want to be behind the dam, it naturally would want to flow downhill. So the movement from unstable to stable, this happens naturally. Maybe it wouldn't, in our first diagram, maybe it wouldn't work exactly like that, because probably if we look at this diagram of these little bricks propped up on one another, what would they normally do? They would normally fall. And they probably wouldn't fall in such a lovely organized fashion as this, but this is a high potential state. This is a low potential energy state. It doesn't want to go anywhere. It will not naturally go anywhere. It will just stay in this state naturally. Even more obvious than our little bricks is if we look at this ball on the hill. Is this ball on the hill at high potential energy or low potential energy? High. High, and we're just gonna, how can we abbreviate potential energy? PE. PE for potential energy. PE is potential energy. Please don't fall asleep, you will miss this. I can do the whole lesson in the Mickey Mouse voice if it helps. Would that be helpful? Shall I do Mickey Mouse for the rest of the class? Or would that drive you crazy? Probably drive me crazy. Okay, so we have this ball. It's at the top of the hill. It is at high potential energy. Does that mean it is stable or unstable? Unstable. So is it going to naturally stay there? No, naturally it will roll down the hill. And it will roll down the hill until it gets to a place where it is at a low potential energy, where it is stable. So nature always tries to go to the most stable state. And that's going to be important because this is why ions form. Let's just do a little vocab review. An ion is an atom or a group of atoms with a net or overall what? Charge. In a neutral atom, the number of protons and electrons are the same or equal. So we have the same number of positives as negatives. Same number of positives as negatives. In an ion, the number of protons and electrons are different, or not the same, or unequal. What charge do protons have? Positive. Positive. And what charge do electrons have? Negative. Okay. If the number of protons and electrons are not equal, the atom will have either an overall positive, oh, that was supposed to be a highlighter. They will either have an overall positive or overall negative charge. If we have an overall positive or negative charge, what do we have? We have what do we call an atom or a group of atoms with a charge? An ion. So we have an ion. Okay. Now here's the big question. Why do atoms form ions? Why bother? They're sitting there happily being atoms. Why on earth would some of them throw away their electrons? Why do some of them want to gain electrons? This is the big question. And it turns out that if you fill the outer shell of an atom, let's look at an atom. If we have the first shell, what is full for a first shell? Full is 2 electrons. If we have the second shell, full is how many? 8 electrons. And if we have the third shell, full is 8 electrons. And it turns out that if you fill up a shell, that is very stable. What does that mean nature thinks of that? Nature says, oh, good, let's go there, let's do that. Let's fill up that shell because then we will be super, super stable, okay? So if atoms have little gaps, they're gonna try and fill them in. If atoms just have a few electrons, they're gonna try and give them away, okay? So an atom is either going to gain or lose electrons in order to have this stable, filled electron arrangement. New vocab here. The outer shell is called the valence or valence shell. Which shell is the valence shell? That is the outer shell. Now, if you recall, what is an anion? A negative ion. Okay? Now, if an atom has 5 or more valence electrons, those are electrons in the outer shell. Okay, valence electrons are electrons in the outer shell. I'm just going to draw over here 5 electrons in the outer shell. 1, 2, 3, 4, 5. Now what we're going to do is we're going to draw in little boxes showing the empty spaces. Is there an empty space on the top? No. Is there an empty space on the right? Yes, so we're going to show the empty space with a little box. There's an empty space on the bottom, and there's an empty space on the left. Is this atom closer to full or closer to empty? Eight is full, 0 is empty. Closer to full or closer to empty? Closer to full, because to empty it out, we would need to take away how many electrons? 5, but to fill it up, we only need to add 3. So we are closer to full. And if we are closer to full, that means that the atom will gain electrons in order to fill that shell. So it is going to gain electrons to fill the shell. Now it turns out that all atoms with 5 or more valence electrons, closer to full, are all non-metals. And we're going to worry about the next blank in a minute. We're not going to go there just yet. We're going to look at our example. Fluorine. That's what fluorine looks like on the periodic table. There's a 9 at the top, a 19.0 at the bottom. What is that top number? That is the number of protons. It is the atomic number. And if we have a neutral fluorine atom, What else is it equal to? It's equal to the electrons in a neutral atom. So what that means is, how many protons do we have? 9. How many electrons do we have? 9. We can count them. 1, 2, 3, 4, 5, 6, 7, 8, and we have a 9th one, and look what's missing. What's happening here in our outer shell? We have an empty space, okay? A 10th electron would fill it up, but right now we only have 9. So what's going to happen is an electron is going to come in here. So this atom is going to gain 1 electron. If you get one negative thing, one extra negative thing, what is your charge? Negative. Negative how much? 1. So if you gain one negative thing, your charge is negative 1. And so we go from having fluorine, which is a neutral fluorine atom. You'll notice there's nothing here, nothing there. That means it's neutral. But if we gain 1 electron, instead of just being F, thank you so much. If we gain 1 electron, what do we have to put up in the top right corner? We have to put 1 minus, or we can just write minus, okay? Or F1 minus, or F minus 1. Any of those are okay when you're in grade 9. By grade 11, I would like you to use this one because this is the most sort of grown-up way of doing it. That's what a chemist would use, okay? But do I care if you use F1 minus? No, that's fine. Do I care if you write F minus 1? No, that's fine. So we have over here, we have F, neutral fluorine, and over here we have a negative. Uh-oh, what just happened? We had a fluorine atom, and when it gained an electron, it became a fluoride ion. Okay? Became a fluoride ion. So when an anion is formed, the ending changes to ide. So instead of fluorine, we have fluoride. So we can fill that in up here. When an anion is formed, the ending changes to IDE. Okay, so we just filled that box in right there. Okay. Yes. It will end up being the same number of electrons. The protons don't change. Protons don't change. No, that's because we're filling them in. That's because we're going to try together. Yes? No worries, no worries. We'll get there. Now, we're going to try this together. All right, and then maybe you'll try the third one on your own. So here we have, oh, before we go on, fluorine would change to fluoride. What type of element is fluorine? What type of element is fluorine? It is a non-metal. So it's also a halogen. If I had chlorine, which is another non-metal, what kind of ions do non-metals form? Non-metals form do they form positive ions or negative ions? You know what's really nice? Non-metal starts with N, and negative starts with N. So non-metals form negative ions. And what do we call negative ions? Anions. And we've got that N again. Okay, so many N's. Non-metals form negative ions, which are called anions. So let's take a look at another non-metal here. I'll wait for you to finish writing stuff and then we'll try another one. Let's look at this other non-metal. And let's look at its outer shell. Here's its outer shell. Okay, there's its outer shell. Are there any empty spaces in that outer shell of sulfur? Tell your partner, point to where there would be empty spaces in sulfur. Point it out to your partner where they are. And now we're going to draw a couple of boxes. Let's draw boxes where we have the empty spaces. There's a box on which side? The bottom. There's an empty space here. Where is the other empty space? On the left. Okay? Empty spaces. Is this atom closer to full on its outer shell, or is it closer to empty? It's closer to full. It only needs to gain 2 electrons, but if you tried to lose it, how many would it have to lose to empty that outer shell? 6, that's too many, okay? So we are going to, are we going to gain or lose electrons? We're going to gain electrons. They're going to fill those empty spots. How many will we gain? 2 electrons to fill the empty spaces. So where do they go? One goes here, and one goes here. So we started with sulfur. Sorry. We started with sulfur. How many protons does sulfur have? It has 16 protons. When it changes into an ion, how many protons does it have? Still has 16. Okay, so we don't change the number of protons, because if we were to change the number of protons, it would become a different element. Now, the symbol for sulfur, do you guys know the symbol for sulfur? S. That is a neutral sulfur atom. And you'll notice I'm going to start throwing some F's into sulfur, even though it says pH, just so you get used to seeing it both ways. Okay? Sulfur can be spelled with either an F or a pH. Now, sulfur, when it becomes an ion, when it becomes an ion, remember it gains 2 electrons. So what charge is going to go up at the top right? It's going to be negative, and negative how much? Negative 2, because we gained 2 negative things. So its charge is going to be 2 negative. It is also okay, if you want to, you can write it as S minus 2. Either of those is fine, okay? So on the left, we started with 16 protons and 16 electrons. So we had 16 positives and 16 negatives, gave us an overall charge of 0. However, on the right-hand side, we gained 2 electrons. So instead of 16, now we have 18 electrons. So we have 16 positive things and 18 negative things, which gives us an overall charge. Or is there more positive or more negative? There's more negative. How many more negative? 2. So there's actually 2 ways to figure out the charge. You can say it gains 2 electrons, 2 negative. Or you can compare the protons and the electrons and say I have 2 more negatives than positives, so it is negative 2. And what are we going to call this ion? Tell your partner. It's no longer sulfur, it's sulfide. Okay? And I think you guys deserve a 5-minute break, and then we're going to come back and do stuff. So stretch, go to the bathroom, get something to drink. Yes? Yes. Which is why we don't bother with 4. When we have 4, they actually, when we have 4 valence electrons in the outer shell, they don't tend to give and take electrons, they tend to share. And we'll look at that in Unit 3. Okay? Uh-huh. Uh-huh. Oh, yeah, that's actually better. I have to be honest with you. I have worksheets like this, but they include things, they're all about the same thing. So I stole someone's worksheet. And so I stole this one, and it makes me a little unhappy. Your answer is more correct than this. Okay? Yes. see if I can pull it up here. Okay, so here we go. We're going to go to sign. And then over here, it's possible that homework might be hidden. And then if we, yeah.
John.
Let's finish this up. If we finish it up, then we have no homework. Yay. All right. Do you want to try this one on your own, or do you want me to walk you through this? You guys get to keep that. It's fine. I don't need it. You want to try it on your own? See if you can do it, and then I'll do it with you, okay? So this is page 98. Try page 98 on your own. Try it on your own. See if you can fill in all the stuff. We are on page 98, and we're trying to see if we can fill it in on our own. If you don't know where to start, you can start by drawing in boxes where you have a gap, where there's an empty space. Anywhere where there is an empty space, you can draw a box. Sophia. Once you know where those boxes are, you can fill in the extra electrons. Okay, so we filled in 1 extra electron, 2 extra electrons, 3 extra electrons. So we can say that nitrogen gains how many? 3 electrons. So the symbol for nitrogen is just N. But the symbol for the, what's the name of nitrogen when it becomes an ion? Nitride. Nitride. And what's the symbol going to be? It's still an N. What number has to go at the top right? 3, because we have 3 electrons. We're going to have a 3 minus charge. If you write it as N minus 3, that's also okay. Okay? You can check your charge. 7 protons, 7 electrons in our neutral nitrogen atom. That gives us a 0 net charge. But in the nitride ion, we have 7 protons. We gained 3 electrons, so how many electrons do we have now? 10 electrons. So we have 7 positive things, 10 negative things. So that gives us 3 more negative than positive. So the net charge is 3 negative. That just confirms that it's a 3 negative charge. Now, where do anions get their extra electrons from? Anybody got any guesses? Who's going to answer me? Okay, pardon me? They get them from other atoms, which will become cations, yes. Okay, they get them from other atoms. So far we've been dealing with nonmetals. What do you think we're going to do next? Metals. So we were looking at nonmetals, now we're looking at metals. And if you have trouble remembering this, remember we had the negative nonmetals. If it's helpful, you can imagine this little cat is wearing a collar. Yes, got a little collar on. And on its collar, what's hanging here? A little metal tag with its name on it, metal, on the cat, metal. So metals form cations. I don't know if that's helpful. You're looking at me skeptically, Matthias, I don't know. Or maybe you're just squinting. It's all good. So metals form positive ions. Why do they do that? Let's take a look at what a metal might look like. That might be a metal, that's its outer shell. Is that closer to full or is that closer to empty? Metals have closer to empty shells. So in other words, there are 3 electrons or fewer. And if you're concerned about that sort of thing, that is the correct grammar. 3 electrons or less would be incorrect grammar. I don't care, but just in case you're the kind of person who does like grammar stuff, it is 3 electrons or fewer. So metals have only a few electrons in their valence shell. Remind me, what is a valence shell? That is the outer shell. And if they have only a few electrons, will they gain electrons? Or will they lose? They are going to lose electrons. So let's look at sodium. Let's see what sodium does. Here's sodium. We have 11 protons in the nucleus. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That shell is full, second shell is full, so we need to put the 11th out here. Is that stable? No. So what we're going to do is we're going to lose an electron. And just so you know that shell doesn't go away, it's still there, it's just empty. Okay, so now our outer shell is empty. So they've written it here as a vacant valence shell, but you could also say that that is empty valence shell. What charge do you think you will have if you lose one negative charge? You will become +1. Yes, if you lose one negative, you become +1. So what that means is that sodium, losing an electron, stops being Na and instead it becomes Na plus. Is good? Okay. Now, here I want you to notice something. Whoa. Look at this. What happens to the ending of sodium when it becomes an ion? It does not change. Metals don't change their names. Only nonmetals change their names. Cations don't change their names. Can you imagine your poor little cat? His name was Fred, and all of a sudden you started calling him Tinkerbell? You'd be like, what? Who is that? Who's that? Wouldn't know. Oh, have you seen the cats on YouTube who have those little pads with all the little buttons? Oh, you need to look up Billy the cat. Billy the talking cat. So cute. Like, goes around pushing all these buttons. Like, Billy's dad has gone away on a trip, and Billy's like, pushes a little button, goes, and that's like asking a question. Dad. Like, it's so cute. I won't tell you the whole thing because me doing it will not be as cute as Billy the cat talking. We're actually done for today. Should we see if we can find Billy? Okay. And you have no homework, so I'm gonna press stop.